Hello, everyone. We're back. Hello, Matt.
Hi, everyone.
So we're back for the second Q&A session, and we got a bunch of good questions lined up here. And before we start with them, of course, we are going to do this again next week. So keep the questions coming. They are very helpful to us also because they make us think about the stuff we write. We still have to write, or the things we already have written. And yeah, it's fun to answer them. So we'll start with a couple of easy ones. So we had a question from Ivan, and he asked about these warnings that we put in there at the beginnings of the chapter that things are still unfinished and might change a lot. And maybe you can say something about that.
We're not planning to make major changes to the chapter, so you can start reading it. But we definitely will make more language changes, and we might make a major change if we really think, or also if we get the feedback that something is not well or not good enough, we might consider it. But we're not planning to. We're hoping to release it as is with only minor changes.
Okay, so the next one comes from, I'm not exactly sure how to pronounce this, from Anders. And that's just a very short one. I will just take this. Will the videos from this book be available on Swift Talk as well? And the answer is no, they are separate. So the Swift Talk series just continues as usual. And the videos for the books, we'll produce them separately and they are sold separately. So then we have a couple of questions regarding terminology. And the first one comes from Peter. And he suggested that, or he pointed out that we don't define the term layer in the terminology section, but we use it. And yeah, Matt, maybe you can take this one.
Yeah, we should probably go back to the book and add that in, but layer is a bit hard because we're really using it as an abstract term for a collection of classes and components that all somehow fit a conceptual pattern. So the model is a layer because all of the objects that you might call model objects are all abstract, not as much as possible, not tied to implementation details. They're separate from the view, and they somehow describe the core state of your program. But things in the model don't necessarily have more in common than that, and they don't follow any greater pattern. They just conceptually fit together. In the same way, things in the view are, they're focused on presenting a state to the user, the display on screen. But things in the view don't necessarily have more in common either. I mean, the view can include text editor fields taking in input. They can include controls. In some sense, the app itself is an audio playing app. The audio is kind of a view in that sense. So things in the view, again, they have something conceptual in common, but they don't necessarily have implementation details in common. But yes, we should go back to the book and attempt to make a definition of that.
Yeah. Awesome. So the next terminology question comes from Anonymous, actually, here, but it's a good question. And the question is about the term unidirectional data flow. And so in the book, unidirectional data flow is defined as a view event that triggers either a model update or a view change, but not both. So, Chris, we had some discussions about this already.
Yeah, I think so. At least Matt and I seem to disagree for a little while. Maybe we don't, maybe we do. There is no clear definition of unidirectional data flow. So most of it is very similar, most definitions, and most people mean almost the same thing, but there are definitely some implementation details which one, or maybe some different implementations, which some people would call unidirectional and some people wouldn't call it unidirectional. So I think it's possible to do unidirectional data flow with model view controller, but I'm pretty sure at least the Redux people or those kinds of people would disagree, because they think of unidirectional as something very different. But the moment you try to write down the definition, yeah, then you could have some interpretations which some people don't feel as unidirectional. So yeah, it depends a lot on the definition, and as with many of the architectural things, the definitions are often very unclear, and leave a lot of freedom to interpretation.
So I think we can definitely do a better job still of defining what we mean with the term and be consistent with that. But it's with every question that asks, like, is A B? You know, it always, what is A and what is B? So, but we have to really make it clear. That's a good point. And then another question that I will also hand to you, because you did the most work on the Elm implementation. And somebody asks, no, it's Peter again. Peter asks, did we consider just using the term Elm instead of the acronym TEA?
Yeah, so T stands for the Elm architecture, and we didn't consider using Elm because it's a programming language, first of all, and because in Elm they call it the Elm architecture, TEA. So that seems like the most natural name, and hopefully the least confusing, even if it's slightly confusing.
Yeah. So then, Matt, I have another Viper question for you. So the question is from Chris, and basically he asks, like, it might be a burden in simple apps to break things up a lot, but if the app becomes more complex, could there be real benefit to that, to using something like Viper?
Yeah. So this question implies something that we don't think is true, and the implication is that to model a bigger program, you need a more complex design pattern. It implies that, you know, if your program is really, really big, then fundamentally your application design pattern has to have lots and lots of different parts to it. And this is what we don't think is true, but maybe there's a disagreement between how we view application patterns versus how we view the design of your entire program. Let me explain that for the most part, an application is really about how you bind the model or the domain to the views. We use the word model in most cases, but in other contexts, it's sometimes called the domain. And the domain incorporates everything that is not directly tied to the implementation of views. Now, in Viper, there's a good two or three components at least that are part of the domain. But in many cases, we're just prepared to call that, well, it's the model. And the reason why we don't want to start bringing all of these separate components into the program, into the application design pattern, is we think that working out how to break your model into different parts is better left on a per program basis, analyzing where you need to break up network communications and sessions, and how different parts of your app might be broken into different features you present to the users, different features and data required for each view. These are all very application-specific ideas, and I don't think the approach of telling people up front you must have a presenter and interactor and entities, and the interactor and presenters must be tied to the lifetime of view controllers. I don't think that's particularly helpful in most cases. In general, what we're talking about in application design is really setting up the views, setting up how the views bind to the model, but your model should be, we think, free to be decomposed however you think it makes sense. So when we say model view controller, we're not saying you can't have a model with 3 or 4 layers internally. In fact, that's a good thing for larger apps. It's absolutely a good thing. But that should be a decision for specific applications. And it's something that you can grow, provided you keep it out of the view controller, provided you're not entangling it with the implementation. then you're free to have an abstraction that makes sense. And if you end up with a Viper-like abstraction, then okay, that's not a problem. But I think you should try and get there organically. And I think you should start from thinking about, well, I've got my views managed. They're getting their data and their presentation from over here. Now I can look at simplifying the representation of my domain logic or improving my abstractions in my domain logic.
Yeah. Thanks, Matt. I think that answers it. There is a little follow-up question tagged to the end of that. And that is like, how do we feel about using multiple architectures within a single project? Chris, do you want to?
Yeah, I think, well, in a way, so what Matt said, I really agree with. So in a way, maybe that's part of an answer. So I think there's a big benefit if you have a single architecture within your entire app, if possible. So if you use MVC in one screen and then MVVM in another, and then Viper in yet another, it becomes harder to find and to find code and to write the code. And so the more unified your architecture is, the easier. But if you have very complex screens, you might split them up into different parts. So in that sense, you could have multiple components within a single, or multiple architectures within a single application. Yeah.
Okay. So then we had a bunch of other questions and discussions around Viper again, and why it's not in the book, or why maybe it should be in the book and stuff like that. And we've already answered a question about that in our first Q&A. So we're just going to refer to that. There we laid out our basic rationale for our decision. So that's in there already. Then we got a bunch of questions regarding model view model with the coordinator. And the first one is from Eugene, and that is about basically the coordinator part. So do we split up coordinators? Is there one coordinator, or does it make to have child coordinators, something like that? And yeah, basically it's about how to structure this coordinator component, which can grow large as well. Do you want to take this as well? We did something in SwiftTalk, something similar a while ago.
Yeah, if your coordinator object becomes very complicated, you should refactor it. As with anything that becomes complicated, and there are multiple things you can do. So you can break it up into separate coordinators if you have very sort of disjoint flows in your app. If another thing you can do is pull out some of the logic. So if your coordinator constructs the view controller and I don't know, maybe instantiate it from the storyboard and set some properties, you could pull some of that stuff out into a method on a view controller or close to the view controller and have the coordinator only call that method. So there are a whole bunch of refactoring techniques you can use for coordinators. And in that sense, they're not unlike anything. And there is no one real answer. Should it be multiple coordinators or one coordinator? It all depends on your problem. If I'd say start with one, keep it simple. If you find it's not simple anymore, then improve it.
Yeah. And on a related note, so with regard to coordinators, we had a discussion, or there was a discussion also going on in the GitHub repository regarding the connection of the coordinator. And so which component should connect to the coordinator? Because currently, as we do it in the book, the view controller, for example, we have this folder view controller, which displays a table view with folders or subfolders. And when you select one, we need to push a new view controller. And so what happens is that the folder view controller has a delegate, which is the coordinator. And so it tells the coordinator, hey, push the new screen. And there was a discussion, well, should the view controller tell the coordinator to do that? Or should this also be looped through the view model? Should the coordinator observe a property on the view model to know when it's time to push a new view controller? Matt, what do you think?
Yeah, we were talking about this and we were saying that a lot of people like to push everything through the view model because that's the point where they set up testing. And so they feel better if everything goes through the view model because then they can at least test an input and an output to the view model. I don't know if it's completely necessary here because there are sort of two problems with pushing it through the view model. One is that the view model is really more about domain and model logic. So for the most part, it's about setting up presentation of model for the view. Whereas talking to the coordinator is really a control layer responsibility and doesn't necessarily need to go from the view controller into the view model and then back out to the coordinator, which is yet another controller responsibility. There's a sort of, it seems sort of conceptually unnecessary. But then there's the second point is, if you're using your view model for testing, are you really testing anything useful when you do that? Is it just a needless diversion through the view model? And I think it kind of is. I mean, testing navigation state is a little bit tricky, and people try and do it in all kinds of different ways. I think ultimately, if you're really concerned about testing navigation state, then you should be setting up some model-like representation of your application's state, either a view state representation or some kind of flow coordinator which with actual model state as part of its representation. Once you do that, I think your testing possibilities are a lot better. With the view model, I think if the intention is simply to pass it up the chain, then you're going to lose sight of it anyway, and you're not really testing anything useful. I don't think it's a bad thing to send it through the view model. I just don't think it's necessary.
I
did I
think
leave
also
anything out?
that there are we chose a particular pattern in the book, but I think it's a good suggestion. So we should include something about that it's not the only possibility, and you can make good arguments for each approach, and also depending on the specifics of what you're doing in your app. And maybe you're doing more in the view model than just looping a view controller event through. So maybe then there is more to test. But I think, the bottom line is that there's no one right way to do that, I'd say. So don't be religious about it. Just see what works for your use case.
With model view model, I think that's much more true than it was of MVC, that there's more than one way to hook it up. You can make your view models own your controllers. We've chosen to have a situation where the controllers own the view model. And so I think that implies a different kind of hierarchy where the view controller doesn't necessarily need to go through the view model because the view model is its child. In a different arrangement, you could have the view models drive the creation of the view controllers and be necessarily a superior parent, in which case there'd be a very different argument for how things should be routed.
Yeah. So then we have a question from Nick, which is an interesting one. He says, I've been wondering for some time how Cocoa Touch would feel if the UI view controller hierarchy had never been added. So for example, instead of having a UI navigation controller, you would only have a UI navigation view. And so this reminded me immediately of AppKit, because in AppKit, we didn't have view controllers in the same way that iOS had them for a long time. And so instead of having a split view controller, for example, there was just a split view. Or instead of a tab bar controller, there was just a tab view. And Matt, you have been working for a longer time with AppKit than I have. So maybe what's it like?
I mean, the short answer is that you need to give behaviors to all of your views at some point. So either you need to subclass every single view for every single instance in your program to give it its specific instance-specific behavior, or you need to have behavior on at another point, giving it to a very standard view. And that ends up being what happens in most cases, which is you end up having to subclass a super view of some kind, normally the window or perhaps one of the container views within the window, and you use it in very much the same way that you'd use a view controller, just to give behaviors to the child views. This is the way that programming was done through the 90s. It's not a very strange thing. It's frowned on a little bit now because it has conceptual problems. Why are you subclassing a window when you don't actually want to change the window's behavior? So that ended up being where we moved away from that approach. But if you're treating your program as buckets of behavior, then the buckets are going to end up in pretty similar locations. There's very different approaches. So when we get to the chapter we do in the book on model adaptive view binder, you'll see a very different way where, again, there's no controllers in that approach, and everything is just done on views. But instead of needing to subclass views, you're creating these little bindings, which are these little standalone instances that encapsulate a single piece of behavior per instance. And then when you build the view, you give them these little bindings, and they get all their behavior and functionality that way. But even in that circumstance, I mean, you're probably constructing things in groups. So there's a way where it still feels like you're giving the functionality to a super view, because you construct the bindings when you construct the super view and all of its subviews together. So there's still a, what would you say, a topographical similarity. But at some point, you do need to create this behavior. So it's got to end up somewhere.
Yeah. Okay, cool. Moving on, we have a question from Tor, and that's an interesting one. He asks, what language features suggest the use of a specific design pattern? There's a bidirectional relationship between design patterns and a programming language's features. Chris, do you want to take it?
Yeah, I think so. It's definitely true that different languages make different things possible, and we can see this, I think, in architecture as well. For example, Model View Controller with all its local view state is really built upon objects and objects that communicate with each other. That's sort of the core of Model View Controller. So it's a very object-oriented architecture. And stuff like the Elm architecture uses a lot of value types and a lot of these kinds of things. And so in a way, that's more functional. And so if a language lends itself to object-oriented programming better, I think it feels more natural to do an object-oriented architecture. And if a language lends itself to functional programming, that might also influence your architecture. And if you think about architecture as sort of the components and the way they communicate, then that also makes a big difference. So now in Swift, we have functions and first-class functions, and we can use that as a way to communicate. So I think that also influences your architecture, or you can have it influence your architecture. In Objective-C, we didn't have functions or blocks back then, so everything was delegates. So that also influences, I think, your architecture, the communication patterns. And yeah, I do think some languages will make it hard to do certain patterns, and some languages will make it easy to do other patterns. In Swift, I think we can do almost all things from different kinds of languages. So we can do very object-oriented programming if we like to. We can do very functional programming, and it lends itself well to most of these paradigms.
I think it's worth noting that with modern languages, though, most of the languages that people are familiar with for app development, C#, Java, Swift, even Objective-C to a certain extent, they're all capable of very similar things and expressing things in very similar ways. So you don't get a huge difference in design patterns between these modern languages. And I think the languages reflect how programmers are taught and the ideas they're taught. So for the most part, you're going to get the ability to do the same things across a lot of common platforms. Until you go to something like Haskell, which had to invent functional reactive programming just to express basic animations, you're not going to get dramatically different things between languages. And of course, Elm came out of, again, needing to represent state in a functional programming language. But in general, you don't get that in more mainstream languages.
Yeah, and I would say that, for example, like an architecture like the Elm architecture is simpler to implement in Swift than it would have been in Objective-C with the value types we have with enums and structs. It's just easier to write. It's not impossible to do that in Objective-C, but you don't get the kind of compile time checks and the safety that you get in Swift. So it feels more at home there, probably.
Yeah.
So the last question we have is a very short question, but a big one also at the same time. It's from Lucien, I guess, French pronunciation, I'm not sure. So he asks, we discuss all these different patterns, and we also said that we don't want to pitch a particular pattern. But then he asked, well, in the end, how do you decide what architecture to use? And he says, I always default to what I'm familiar with. And I would say, first of all, what you're familiar with is an important consideration. I wouldn't just throw this out of the window. It's one important factor. But yeah, next to a couple other factors, I'd say. Matt, do you want to expand on that?
Well, I would say very quickly, if you're only familiar with one architecture, you should try other ones, because if you're only familiar with one architecture, of course you're going to choose it every time. Yeah, don't start a new programming language don't start a new architecture on a new project if it's a big, important project. Always experiment with these things and become familiar with them first. But, you need to play with these things to see what you like and to see what works with your ideas. If you're the sort of person that just wants the simplest, lowest friction way to use something and just needs the maximum amount of documentation online to help you through it, then maybe you should just go with the default pattern on your architecture. If you like to express yourself through data dependencies in your application, then maybe you should find an architecture which supports expressing yourself through data dependencies or reactive programming. If you're the sort of person that likes to set everything up in state and be able to say, hey, look, here is the state of my whole application, I can just log it out to the console, maybe you should find an application architecture that supports, a complete representation of state. So there's both your own knowledge, you need to have good knowledge yourself to make an informed decision, but then, of course, you need to play with these things and sort of discover who you are as a programmer. You don't necessarily know what you like until you try these things. So obviously, choose what you like. I'm not saying ever anything else than that, but explore things so you know what you like.
Yeah. So I think we thought about this for a while, and in the end, we are convinced that you can write any application in any architectural pattern, basically, and have clean code if you are disciplined and stick to a set of decisions you've made. And so the choice which pattern to use has much more to do with these kind of personal and soft factors, like what you're familiar with, what you prefer, but not just you, but also, are you working alone on this project? Are you working with others? Are there considerations regarding hiring new people, bringing people in and out of the project? All these kind of things are more social considerations often than really hard technical ones. And for example, I can just say from my experience, so Chris is much more, for you, it's much easier to just jump into new things and just try out new techniques, and you get much more out of that to try new things than I do. But I benefit a lot from you doing that, because then I see things that I wouldn't have seen otherwise, and it really benefits me in terms of widening my horizon, basically. But yeah, I think there are big differences in between people, how much they like to experiment or how high the hurdle is to try something new, and all these factors are important when it comes to that. So that was our last question. We are through. We'll do the same next week, of course. So send us questions via email, via Twitter, on GitHub, however you like, and we will do the best to answer them again in a week from now. Thanks for joining us, Matt.
Thank you from the other side of the world.
Cool. Then see you next week.
See you next week. Bye.
Bye.